Hello friends, myself Halavath Ramesh, Department of Chemistry, Laila College, Chennai. Today we will talk about general topic spectroscopic identification of organic compounds. And you can see that everywhere people are going various areas in research, especially in chemistry. Then suppose if you how to identify the particular unknown organic compounds, today we will discuss. So learn chemistry, think chemistry and practice chemistry. So you can see the first slide, spectroscopic identification of organic compounds. How to identify the organic compounds, today we will discuss. Spectroscopy is an advanced powerful tool for the elucidation of structure of the molecules. However, there is no single spectra which gives the complete information about the structure of molecules. In order to get complete structure information, various spectroscopy methods are to be used. Suppose if you are synthesize any compound from the single one spectra, we can't predict the compound structure. Okay, so many spectroscopic techniques are involved in that. Steps for the identification of structure of unknown organic compounds by spectral data. What are the steps? Total 9 steps are involving. These 9 steps you can use and you can find out the unknown organic compounds structure. Okay. So steps for the identification of unknown organic compounds by spectral data. First one, calculation of molecular formula. And second one is index of hydrogen deficiency. And third one is interpretation of IR spectra data. And fourth one, interpretation of UV spectral data. And fifth one, interpretation of NMR spectral data. Again NMR have the 4. Okay, first one is the proton NMR, C13 NMR, depth and the 2D NMR. And sixth one is predicting the possible structure. And seventh one, identification of correct structure. And eighth one, mass spectral fragmentation. And ninth one, report. These 9 steps you can use and you can find out the unknown organic compound steps. Unknown organic compound structure and formulas. Okay, you can see the first one step, calculation of molecular formula. The molecular formula can be calculated the isotopic abundance or nitrogen rules. Using of nitrogen rules and isotopic abundance, and you can calculate the molecular formula. And second one step is the index of hydrogen deficiency or double band equivalence. How to find out the double band equivalence? So DBE, double band equivalence, equal to number of carbons minus number of hydrogen by 2 minus number of halogen by 2 and number of nitrogen by 2 plus 1. Here you can see the molecular formula of methane, CH4, and you can do these values in DBE formula. No double bonds are present. For example, if DBE is 4 equal to the aromatic rings. Suppose it is 4, it is the aromatic ring. Next one is, third one is the interpretation of IR infrared spectral data. So how that IR spectroscopy, infrared spectroscopy used to predict the molecular formula and structure of the unknown organic compound. So IR also is playing the major role of spectral data extraction. To identify the functional groups using stretching and bending vibrations. To using the functional groups, IR is the main concept is to using the functional groups, stretching and bending vibrations. Next one, IR spectral data. Use the information regarding the functional group present in the compounds. An IR spectrum is represented in a graph of infrared light transmissions on the vertical axis versus frequency on the horizontal axis. Typical units of frequency used in IR spectra are reciprocal centimeters, or sometimes it called wave number, with the symbol of centimeter inverse. Suppose if we think that IR, infrared spectroscopy, it gives the information about the functional groups. The IR spectra is represented as the x-axis and y-axis. Suppose if we consider vertical and horizontal. So vertical is the light transmitted, the infrared light transmitted, and the horizontal is the frequency. But reciprocal it is called nothing but of wave number. Okay, that is centimeter in unit is centimeter. Frequency here is given the some range of frequency, and what are the functional groups it will be gives the interpretation. Suppose 3500 centimeter inverse it gives the OH group, and 3300 centimeter inverse it gives the NH group, and 3000 aromatic hydrogens and the aromatic carbon and hydrogen, and 2900 CH aliphatic. Next one, fifth one, see 2110 carbon triple bond, and the 1720 carbon double bond O means ester, and 1700 is carbon double bond of acid plus OH, 1680 carbon double bond O of ketone no OH, 1500 to 1600 carbon double bond of aromatic, 1100 is the carbon 0 carbon of esters, 870 to 690 mono-substituted aromatic rings. These are the range of frequency in centimeter inverse. These are the functional groups for IR. Let us go the next one. Fourth one step is the interpretation of UV spectral data. UV means ultraviolet. So ultraviolets here transparent above 200 nanometers indicate the compound is saturated or aliphatic. So suppose that UV spectral, if you think the transparent is above 200 nanometer, that indicate the compound is saturated and aliphatic. For example, CH3COH or CH3CH2CH2CH2CH2CH3. Suppose the above 254 nanometer indicates the compound is aromatic. Example is benzene. 262 nanometer indicates the alkyl substituted aromatic compounds 5 to 5 star transition like benzyl. 280 nanometer indicates the N to 5 star transition is in conjugated with aromatic ring benzoyl. These are the some interpretation data in UV spectra, ultraviolet spectral data. 5 to 5 star transition, N to 5 star transition, 5 to 5 star transition we can find out from the UV spectra. And next step, earlier we will discuss this step after NMR spectral data and the interpretation of possible structure and identification of correct structure and mass spectral fragmentation. Next video I will upload you. If you like this video, please like, share and comment. Thank you for your watching this video. Thank you, like, share and comment. Bye. See you. All the best.